Hey everyone, welcome back. Today we're going to do a deep dive into camera systems. You know, the tech behind everything from our smartphones to self-driving cars.
Yeah, really exciting stuff.
We're going to unpack the key requirements, look at the architecture, and even try to peek into the future of this field.
Right. And it's a field that's, as you said, evolving so rapidly.
Absolutely.
Yeah.
And I think we're going to cover some surprising facts along the way. Like, did you know that AI is actually changing how cameras are designed now?
It is. It's really remarkable how AI is influencing not just what cameras can do, but also the actual process of designing and building them.
Yeah, we're going to get into all that. But
Yeah.
first, why don't you give us a little bit of context? You know, like, why is camera technology such a hot topic right now?
Well, I think the demand for higher resolution, more advanced features and things like computer vision, being able to actually see and understand the world, that's driving a ton of innovation. And it's really pushing the boundaries of what's possible.
Okay, so let's start with the basics. What are the essential ingredients of a camera system?
Sure.
I know we talk about megapixels all the time,
Right.
but what are some of the other key factors that really make a difference?
Well, you're right. Megapixels are important, resolution, we call that, but they're just one piece of the puzzle. It's really about understanding the specific requirements for each application. So, for example, a smartphone, you know, they might boast 108 megapixels.
Right, for those super detailed photos.
Exactly. But then you have something like a self-driving car, which might actually prioritize a lower resolution, maybe 8.3 megapixels, something like that. And that's because they need to focus on real-time processing.
Makes sense. Different tools for different jobs.
Exactly.
Speaking of different needs, how does frame rate play into all of this?
So frame rate is how many images are captured per second.
Right.
And it's crucial for accurately capturing motion. So think about analyzing a golfer's swing or monitoring like high-speed machinery. You need a camera that can keep up with the action. And we're even seeing high-speed cameras capable of capturing 1 million frames per second now.
1 million frames per second. Wow. That's mind-blowing.
Yeah.
Okay, so we've got resolution and frame rate. What about situations where the lighting is tricky?
Right.
Like a sunny day with lots of shadows.
Yeah, that's where dynamic range comes in. And it's the camera's ability to capture detail in both the bright and dark areas of a scene. So we're talking about high dynamic range, HDR imaging.
Okay.
That's key in a lot of different areas. Autonomous driving, photography, surveillance. Think of a self-driving car navigating through dappled sunlight.
Right.
Or a security camera capturing footage at night. Without good dynamic range, you lose crucial information in those shadows and highlights.
Right. You can't see what's going on.
Exactly.
So HDR is like giving the camera supervision
You could say that, yeah.
to see detail, even in challenging lighting.
Mhm.
Okay. Now, what about noise and latency? Those seem like important factors, too.
Right. Absolutely. So noise, we measure that with what's called a signal-to-noise ratio, or SNR.
Okay.
And basically, a higher SNR means you get less of that grainy look, that you might see in low-light photos.
Right.
And then latency is the delay between capturing the image and when it's actually available for processing. So in real-time applications like robotics, every millisecond counts.
It's amazing how many factors are at play,
Yeah.
even before we start talking about the actual hardware. Speaking of hardware, I'm curious about the architecture of these systems. It's not just a lens and a sensor, right?
No, definitely not. There's a whole ecosystem of components that work together. And one of the key players is what we call the image signal processor, or ISP.
Okay.
Think of it as kind of a digital darkroom.
Okay.
It takes that raw data from the sensor and it transforms it into the images that we actually see.
So the ISP is where the magic happens.
That's right.
What kind of processes does it handle?
A lot. It handles things like denoising. So that's cleaning up that graininess we talked about, color correction, making sure colors look natural regardless of the lighting, and of course, HDR techniques that we talked about before.
So it's like having a professional photo editor built right into the camera.
Exactly.
That's pretty cool. It sounds like the ISP is doing a lot of heavy lifting. Are there like different types of HDR techniques?
arvr.
Is it a one-size-fits-all situation?
No, not at all. There are actually quite a few different HDR techniques. One approach is what we call digital overlap. So the ISP rapidly captures multiple exposures, and that helps to minimize motion blur.
Okay.
And then you have techniques like subpixel HDR, which actually split individual pixels on the sensor to squeeze out even more dynamic range.
Oh, wow. So there are a lot of clever ways to achieve that HDR effect.
There are, yeah.
So how do engineers decide like which HDR technique is best for a particular application?
That's a good question. And it's kind of a balancing act. So engineers have to consider things like cost, complexity, the desired image quality. A high-end smartphone, for example,
Yeah.
might opt for a more sophisticated HDR technique because they really want to deliver those stunning photos.
Okay.
But then you have a security camera, which might prioritize a less complex method to keep costs down.
Right. It's like choosing the right tool for the job,
Exactly.
but with like a whole lot of technical considerations thrown into the mix.
Definitely. And as we move towards even more advanced features like 3D imaging or event-based cameras, this whole integration of hardware and software becomes even more crucial.
This is making me realize that a camera is more than just a camera,
Oh, absolutely.
because this sophisticated system of interconnected components, each with its own role to play. And that complexity brings us to the question of data paths, right?
Right.
How does all the information flow efficiently between the sensor, the processor, and the memory?
You're getting to the heart of it. Efficient data flow is absolutely crucial for these systems.
Right.
And we need to think about buffering strategies, how to optimize memory access patterns so that the system can handle these massive amounts of data, especially as we move towards higher resolution, higher frame rates.
So it's not just about having like a fast processor.
Right.
It's about making sure all the pieces of the system are working together efficiently.
Absolutely.
It's like a well-choreographed dance.
Yeah, that's a good way to put it.
But speaking of choreography, I was reading about how AI is actually being used to design better camera chips.
Yeah.
Can you shed some light on that?
Sure. So that's an area that's really starting to take off. AI is being used for things like logic synthesis. So that's figuring out the most efficient way to design the circuits themselves. It's being used for place and route, which is optimizing the layout of components on the chip. And it's even being used for power analysis to try to minimize energy consumption.
So AI isn't just changing what cameras can do, it's changing how they're built.
It is.
That's amazing. It sounds like the entire design process is becoming uh, more intelligent,
Yeah.
more efficient.
It is. It's like having an AI assistant working alongside the engineers, helping them to create these increasingly sophisticated and powerful camera systems.
And this is just the beginning, right?
Yeah, I think so.
AI is also playing a huge role in ensuring that these systems work flawlessly through things like formal verification, simulation, and debugging.
That's right.
So we've talked a lot about, the kind of nuts and bolts of camera systems,
Right.
but let's take a step back and talk about like the real-world applications. We mentioned autonomous vehicles briefly,
Yeah.
but what are some other areas where this technology is really making a difference?
Oh, there are so many. I think we should start by exploring how cameras are revolutionizing things like augmented reality, consumer electronics, and then, of course, the unique challenges and opportunities that each application presents.
Let's do it.
Let's dive into augmented reality and virtual reality first. AR and VR for short. These technologies rely heavily on cameras to, capture that real-world environment and then blend it with digital content.
Yeah, AR is so cool. I've played with like those AR apps where they, overlay digital objects onto your view of the real world. But I can imagine they creating like a truly smooth and realistic AR or VR experience. It must take a lot of technical, finesse.
It does. You're absolutely right.
What are some of the challenges there?
Well, one of the biggest challenges, especially with AR, is latency. So the cameras need to be able to capture and process images with like minimal delay so that those virtual elements stay perfectly aligned with the real world as the user's moving around.
Right, so you don't get that weird lag.
Exactly. Any lag can really break that illusion and in some cases even cause nausea.
Yeah, nobody wants that. And I bet the resolution and field of view of the cameras are important too, especially for like VR headsets where the entire visual experience is coming from the cameras.
You're exactly right. For VR, you want high-resolution cameras with a wide field of view to really create that immersive feeling. You also need precise synchronization between multiple cameras, to make sure that virtual world feels natural and comfortable. And then there are challenges like correcting lens distortion and integrating eye tracking to make the experience even more realistic.
It sounds like designing these systems is a real balancing act. You're juggling like so many different factors
It's
to
true.
create that seamless blend,
Yeah.
between the real and the virtual. Okay, well, let's shift gears a bit to something a bit more down to earth, literally.
Okay.
Automotive vision systems.
Right.
They're becoming incredibly sophisticated,
Mm.
with cameras playing a key role in everything from parking assistance to fully autonomous driving.
Yeah, it's amazing how far automotive vision has come, and cameras are now, really essential for those basic safety features, lane departure warnings, automatic emergency braking, and as we move closer to self-driving cars, they're even more important.
I can see how cameras would be crucial for those advanced assistance systems. But what are some of the specific challenges in designing camera systems for those autonomous vehicles?
Right.
I mean, it seems like you'd be a lot more demanding than like just sticking a webcam on
Oh,
a dashboard.
yeah, for sure. A simple webcam wouldn't cut it.
Right.
So one major challenge is dynamic range. So think about, a car driving from bright sunlight into a tunnel.
Well, yeah.
Those cameras need an incredibly wide dynamic range to be able to handle those rapid lighting changes and, still capture details in the shadows and highlights. And then there's low light performance, which is obviously essential for navigating safely at night or in, bad weather conditions.
Right, right.
So it's not just about capturing clear images,
Right.
It's about capturing images that the car's computer vision system can actually understand.
So it can react in real time.
Exactly.
Yeah.
So the cameras need to be able to accurately identify and track things like other vehicles, pedestrians, cyclists, road signs, and all of this needs to happen, incredibly fast.
Yeah, I mean, with speed and accuracy, we're talking milliseconds here.
We are.
So it's a real testament to how far both camera and AI technology have come.
Absolutely.
It's kind of mind-boggling to think about the amount of data being processed like every second by these systems.
It is.
How do they manage all of that information without like the car's computer just being completely overwhelmed?
Well, that's a great question, and it highlights the importance of efficient data handling.
Okay.
So, autonomous vehicles generate a ton of data from their cameras, and this data needs to be, compressed, stored, transmitted,
Right.
all without any, hiccups.